Thanks a lot for this kind introduction. I must thank Dnyanshree and Rotary Club for inviting me to speak about this important subject. I was going to speak, talk about respected dais, but I think dais has gone down. So, respected friends, the topic that I'm going to talk about is extremely important and in fact quite earth-shaking. Normally when I give a talk to the students, I would say get frightened, but certainly students get moved by what's likely to happen in the years to come. The changes that will happen in the future are really astonishing, to say the least. For instance, the rate of change is extremely high. So I think, since you are professors, I think that's something that you should invite, that you should certainly pass on to your students, because the world is going to change far more rapidly than it did when we were students, for instance. To give you a perspective, 14 billion years ago the universe began, according to the Big Bang theory. The Earth originated 4.5 billion years ago, and the first living being came into existence 3.75 billion years ago. And then there was evolution, then mankind arrived. Human history spans 3 epochs, according to Alan Toffler: agriculture, industry, and services. Agriculture spanned for tens of thousands of years, but there was no progress, there was no technology. The way we lived yesterday was the same the way that we live today, and the same way that we would live tomorrow. And then weeks and months and years and decades and centuries and so on and so forth. So for tens of thousands of years there was no change in the way we lived, because there was hardly any technology. Then came industrial revolution, and only in a few centuries the progress that we made was much higher than the progress that we made in tens of thousands of years of agriculture. And then came modern services. Modern services started in 1960 onwards with the advent of computers, modern banking, insurance, and so on and so forth. Though they actually originated a few centuries ago, but the modern banking, modern insurance, modern IT, and all that began after 1960. And the progress that we made in services era, that is a few decades, was much higher than the progress that we made in a few centuries in industry, which in turn was much higher than the progress that we made in tens of thousands of years of agriculture. So I think all of you professors know mathematics. So we talk about d2 by dx story. It's exponential, growth is exponential. So we can't extrapolate what's likely to happen in the next 10 years by just looking at last 10 years. We can't. Because the progress is much higher than what was the progress in the last 10 years. That's the kind of story. To give you a statistic, the progress, the technological progress, mankind, we have not progressed by the way. We still catch each other's necks, and we still go to war and so on and so forth. So we have not progressed as human beings, but in terms of technology, the progress that we made in the last 10 years was much higher than the progress that we made in the entire history of mankind. Does it mean that we have suddenly become intelligent? We have not. Like Newton used to say, these are standing on the shoulders of Galileo, Copernicus, etc. We are standing on the shoulders of hundreds and thousands of researchers here in IIT, IFRs, and MIT, Stanford, and so on and so forth. Hundreds and thousands, and many corporations. So obviously the growth is multifold, and that's likely to continue. If you look at only the services era, 1960s was the era of mainframes, 70s was mini computers, 80s was the era of personal computers, 90s was internet, 2000 was mobile computing, and 2011 was the announcement of Industry 4.0. I'm going to talk about this. But before I go into Industry 4.0, now Industry 5.0, 2017, 18, etc., when ChatGPT also started, as you know, large language models. But I think it's very important to understand how we came to this stage and what are the changes that are likely to happen even before AI and Industry 4.0. Because before that, the changes that were predicted were really path-breaking, were quite prophetic. And I think though all of those have not sort of materialized as of now, many will materialize in years to come. I think that's something that we need to take lead of. It's very important that we understand what's likely to happen, so that we're not sort of taken by surprise. In 60s was there was the era of mainframes when they were very large. People did not used to believe in them. They were purchased because of showbiz. Chrysler had a computer, so Ford had a computer, Ford had a computer, so General Motors had a computer. They were only used in batch processing and only for data storage and databases and so on and so forth. They were used to use punch cards, sometimes tapes. There was no real time. Today we press a key in our airline ticket is booked immediately. That was not the case then. You would feed the punch card, take a listing, correct those, and again, and so on and so forth. Until such time that the data was correct, then take out the reports. The report used to come very late. So users did not believe in the computer. I was an IBM then, we used to go to the customers and users and said, used to request that, please give us some work, and they used to throw us away. Or they did not used to believe that computers did something useful. Because manual reports used to come far earlier and far more accurate by the way. Then came 70s, the mini computers, the prices fell, the sizes fell, the online processing, there was some communication protocols arose amongst the manufacturers, like IBM had SNA and Digital had Keynote and Data Journal and Zodiac and so on and so forth. So those two data journal computers could talk to each other, so IBM computers could talk to each other, but Internet had just begun, ARPANET had just started, but when Internet arose in 1990s, then computers of different makes, including PCs and mainframes and mini computers and LANs and WANs and so on, all could talk to each other. That was in 1990s. But the real revolution took place in 1980s personal computers. Sizes fell, prices fell. For the first time there was multimedia, for the first time there were colors, there was GUI, and for the first time users could believe in computers. Because they could touch, feel, use, and so on. They didn't have just look at mainframes from outside, a very large glass window, where the programmers used to run around with punch cards, and they used to look at it with frightening eyes. And there were only two places that people used to remove chappals in those days. Outside a temple and a mainframe computer. Because in both the places they did not know what was happening inside and how decisions were made. So it was much safer to remove chappals at that time. But then in the 70s, mini computers, 80s, with personal computers, people started trusting computers for the first time. That's when computing actually invaded all walks of life: education, retail, manufacturing, and so on and so forth. And that's when business process re-engineering arose. All of you who've done management will probably know that business process re-engineering is throw away the old process. Process means the way you do things, like purchasing, inventory, manufacturing, and so on. The way you do things, payroll. Throw away the old process, build the new process using computers and communications. Because for the first time, information technologies boldly made a statement: please use me, not please, actually better use me. It dictated terms to businesses. Earlier, we used to beg to business, please give us some word. And IT was a tertiary, some kind of, also nice thing to have, but put in a corner. But now IT became central, and all the businesses actually were built around information technology. Information technology is computing and communications together. I'll give you a couple of examples. ATMs came, and the complete cash deposit and withdrawal systems changed. The process changed. Earlier you used to go to the bank and you used to wait until your turn came and you used to be given a token. You went to the window and the teller clerk used to dispense with cash. With ATMs, all that is vanished. So the teller clerks are jobless, and unless they learn something new. So this whole question of obsolescence and unlearning and learning and old skills becoming obsolete started in 1980s. In fact, it started with technology itself, but with 1980s it actually the speed was much higher. So the similar case was with CAD-CAM. When CAD-CAM came, all the draftsmen had to learn something new, AutoCAD or whatever, otherwise they were jobless. With word processing and DTP, the typist's job vanished. Earlier, the typists, if you remember, every corner, many of you may not know, but nowadays the typists used to know the corner of the road. And with carbon copies, you used the typist used to type a line and then the roller used to come back at the next time and so on, and there were erasers to change and so on, to correct. With word processor, all that went. But there were many facilities with word processor. With DTP, of course, much more. In fact, today no messages are reading. If, for instance, if there's a newspaper, there's an American president who is murdered at 10 o'clock in the night, if a newspaper says, I'm not going to use DTP at all, I'm going to use the old-fashioned Marathi case only, each page has to be set, properly, and then have to print it. At 10 o'clock the page was ready, so you couldn't do anything at all. The news had to be printed next day, the evening newspaper, whatever. But with DTP, in 10 minutes, you cover all the news of the murder of the American president, move to the first page, whatever material you want to move, and then move back to the fourth page, whatever you want to be printed on the first page, and redesign the page in a few minutes, and then your paper next day at 7 o'clock is ready. If a newspaper says, I am not going to use DTP, that newspaper will not survive. So that is the point that I am trying to make. In 1980s onward, information technology became central. It started dictating terms that better use me and build your business around me. If you don't do that, you will be thrown out of business. And that's when IT became really very powerful. That's exactly when American businesses started redesigning their systems. And that's why there was a shortage of programmers. The rate of programmers was $150 an hour, and then $20 an hour. Actually, I was heading Patni at that time. They just left Patni and started Infosys. I ran Patni for 11 years, sitting in the same chair. And then became managing director, etc. But I think that's when we used to New York or wherever, in fact, Mukti and Nandan and all those. And when many of the companies, we used to, in fact, I remember having made telephone calls when it was going outside from public telephones to the prospects and so on. But there was hardly any credibility of India. They thought India was full of elephants, magicians, and serpents. But we made the credibility, and ultimately, there were 100,000 people went to America. It was on-site programming. The credibility was built. In the 1990s, it was a separate thing, and then internet. Therefore, all the Pune, Hyderabad, Chennai, Delhi, all the software development centers came about. But let's leave aside the history of Indian IT industry. But 2000 onwards, there was mobile computing. But even before that, by the way, the kind of changes that were predicted, I want to really bring to your notice. It's very, very important because those changes will happen in the next 20, 30, 40 years. I don't know how many years it will take to effect those changes, but I think they certainly will happen in this century. Whether they're 2 decades, 3 or 4, I don't know, but they are extremely, their impact is going to be very, very wide, and I'll tell you a few. First of all the notes, credit cards, coins, debit cards, checkbooks, all of these will vanish. Now that is trivial. 15 years ago, when I used to speak about this, people did not used to believe in this, but now with Paytm and GPay, etc., we know that there is no need for this. When I work, my salary or money it comes to my mobile in zeros and ones, and when I spend, it goes out with debit and credit, obviously, from my account to the shopkeepers or whatever. There is no need for any, in China for instance, hardly any currency, and that will happen. Nandan Nilekani is going to, my friend, in fact I asked Nandan whether it will happen in 10 years or 5 years or whatever. He is very optimistic. There is a lecture on the future of financial services given by Nandan. Please go ahead and go and listen to it. But that is trivial in my opinion. Next is all offices will become museums. All offices. There is no reason for any office to exist. Please understand this. I mean, when I used to be the managing director of a company with running software companies of thousands of people and having software centers in Chennai, Bangalore, Pune, Mumbai, etc., what did I used to do? I used to go to my secretary and say, call my managers of either Europe, America, whatever, or if in India, then South, West, North, East. And I used to go to the conference room and they all used to put the PPTs and so on. And if the southern sales were down, then I used to discuss why they are down, and he used to give reasons and so on. All that can be done staying at home. All of us are sitting at respective homes and there is a screen. On television today, there are 4 windows, and one is talking from Calcutta, one is from London, one is from New York, one is from Pune. Data can be shared, they can still fight, which we do on the television screen, as you must know. So basically all the discussions, fights, decisions, data sharing, all that can be done without traveling. With the banks, why do you need hundreds and thousands of branches of banks? With ATMs you can withdraw and deposit cash. if you want to apply for loan, you can apply on the internet. You can attach your property documents. They can be checked online, by the way. And then loans can be passed. Loan comes in zeros and ones on your mobile, and then you can spend it. Why do you need these hundreds of offices? Why do you need offices of insurance, where the stock exchange? Ask yourself a question. And this in COVID, of course, has shown that many things could be done sitting at home. Many IT companies are actually work from home 50%, for instance, or many, whatever, 30, 40, 50%. There are pluses and minuses of this. I get asked a question quite often that what will happen to social life? But I would probably argue that social life will improve, because you're spending 3-4 hours in Bombay locals and now in Pune also to travel to and fro. All that will be saved, and you can actually meet people that you couldn't or you are not able to today. You will meet people that you want to meet, but you can't because of the time that you waste in traveling. You can go and play chess, maybe swimming, maybe mountaineering, maybe play music, attend concerts, etc. in the time that you have saved because of traveling. So it's a debatable question. I'm not saying it is good or bad, but this is likely to happen, that all offices will become museums. What will happen to property prices then? I mean, I'm just throwing a question that you should really ponder. Bill Gates has written a book called Business at the Speed of Light in 1996. Go read it, definitely. Because one of the things that he has said, which is quite prophetic, he says that all middlemen will be finished, will vanish. All middlemen will vanish. So you will be directly through internet connected to the producer. Today, Amazon also is a middleman, by the way. Flipkart also is a middleman. Ola, Uber also is a middleman between you and the driver because of the software that they have produced, right? Or Amazon because of software and hardware, warehouses, etc. So Amazon also is a middleman. So if you want to purchase a book, the publisher and you, there is one middleman, is a big middleman, Amazon. And with blockchain, I won't have time to go through that. Read my book. I will explain that. Because of blockchain, even Ola, Uber, and big middlemen also will vanish. But my prediction is that initially only big middlemen will continue. Smaller middlemen will vanish. Take an example of why do you need the shops selling shirts? You can directly go to the website of Raymond's or Louis Philippe or whatever and say blue shirt and 40 size and half shirt, etc. With augmented reality, which is part of Industry 4.0, by the way, augmented and virtual reality. With augmented reality, you can actually see how the shirt will look on you without purchasing it. So you don't really need the shops displaying shirts. Same is true about shoes. Same is true about many cosmetics. Same is true about paints. There's like Dulux, and there are many companies who allow you to see on your mobile as to how your room will look like if there's a red color here, green here, and yellow. That's bad combination, but you don't try doing it. But just for an example. But if you do that, how your room will look like is something that you can see on your mobile and then choose and then actually purchase from a producer. Why do you need these shops? Why do you need shops selling tiles? There's a ad in the TV, if you've seen, there was a mobile, you can see, okay, the granite and this design or, all that, and then check how your floor will look like if you choose this tile, and then choose and then purchase. So the middlemen will go away, travel agents will go away. Earlier you used to go to a corner shop travel agent and book a ticket. Now you can book on the internet, for instance, directly from railways or. So why do you need this? There are many bookshops are closing today every week. So this is what will crores of people working in those shops do? What will happen to the property again? Prices, the shops which will be empty. What will happen? See, I'm just trying to say what's likely to happen in this century. This is prior to Industry 4.0 and AI and all that. Now I'll come to Industry 4.0. After the decade of mobile computing, in 2011 in Hanover, there was an announcement of Industry 4.0, and then after a few years, there was Industry 5.0. There's not too much of a difference, but refinement in terms of human and computer interaction. But ultimately, Industry 4.0 comprises mainly 8 technologies. Artificial intelligence being the most important or primary of them. Then there is big data. Then there is IoT and IIoT.
There is Internet of Things and Industrial Internet of Things. Then AR, VR, there is augmented reality and virtual reality, 3D printing, then blockchain, 5G, cloud computing. So these are essentially the technologies which are important in Industry 4.0, but artificial intelligence and big data, which are very cooperative technologies, I must say, are extremely, also IoT and IIoT, that they are very, very important technologies in Industry 4.0. So all these put together are going to change the world enormously. And I will give you examples of IoT, IIoT and 3D printing initially, or maybe 3D printing initially, because I won't have time to elaborate all these 8 which I have in my book, but I think it's very important to understand the basics of these technologies, how they'll affect us and so on. With 3D printing, earlier our manufacturing was subtractive manufacturing. So like a sculptor takes a piece of stone and removes the part that he or she doesn't want. So removes, so subtract. In manufacturing, for instance, you had a design, and then design was digital design kept on the disk, and then you could use lathe to remove the portion that you don't want. Earlier you used to do manually, then you used to have NC machines and so on. But regardless, it was subtractive manufacturing. So take a piece and remove what you don't want, and then you produce what you want. With 3D printing, it's additive manufacturing. So a digital design of what you want to manufacture is kept, and if molten or in powder form, the material is fed and the piece is manufactured layer by layer. Now look at this, this is very interesting. And there are many things in dental procedures and airlines and many industries which are now being produced with 3D printing. With 3D printing, there's a talk, it's very hard obviously, but talk to actually produce human organs. With 3D printing, a building has been created, with 3D printing a temple was constructed. So if the real challenge is doing this, there is no mass production of 3D printing. If that can be done, then what will happen to civil engineering, what will happen to mechanical engineering, what will happen to the whole production process and distribution process and so on. It's going to revolutionize things. With augmented and virtual reality, for instance, the whole travel and tourism industry is going for a shock. Because with virtual reality, you can actually, the whole aim, we are still not there by the way, these are all, will happen in the next 10, 20, 30 years, but the speed is extremely rapid. That's why I gave you an example of agriculture, industry, services, etc. So it's exponentially growing. In fact, the whole reason why Facebook changed itself into Meta was to give you an experience of meeting. Up to now, you could just exchange through messages. Can we give an experience as if you 4 people, instead of only exchanging text messages, can I give you an experience or feeling of meeting and discussing in a restaurant in New York, where actually one is sitting in Pune, one is sitting in Satara, one is sitting in New York, one is sitting in London. This was the aim of Meta at that time. It's difficult. But with virtual reality, in future, you can actually sit here in Satara and it can give you can experience as if you are in front of Niagara or you are in front of the Eiffel Tower or whatever. So the need to travel to experience will actually, I won't say vanish, but will reduce. So it's going to affect the travel and tourism industry. So likewise, in Industry 4.0, there are several technologies that are going to revolutionize and change the way we live. So you must understand. Now I will focus on data, big data and AI. That is very important. With artificial intelligence, actually the term was coined in 1956 with Dartmouth conference in the US. Though the idea came much earlier, 1933, Asimov had actually put forward rules of three rules for robots. In around 1940, Alan Turing actually put forward a test for intelligence, what is meant by intelligence and so on. But AI actually went through many phases. There were many AI winters and many AI summers, if you want to call it. And it had many phases. Like it initially started with expert systems. Expert systems essentially means that study the way doctors work, engineers work, oil exploration experts work, and so on, or lawyers work, and learn their trick and put them in a program, if then else. Like the doctor says, if fever, then give yellow tablet, if cold, then give red color tablet. I'm just simplifying. And then after a week you come back and the fever persists, then give injection and so on, otherwise take an X-ray. So it was all if then else rules. It was filled with that is called symbolic or top-down approach. So it was all filled with if then else kind of rules, but they were very complex to execute. So the whole expert systems era was not very successful. Though many people had invested in many companies, in companies who produced expert system software, but it was not very successful. And then the robotics. Robots actually started much earlier, 1958, with the first industrial robo by a company called Unimation. I had an occasion to meet in Connecticut the person Engelberger, who actually produced that and used it in Ford. But robots then had their limitations. They are progressing very fast, by the way, especially the axis of movement. I mean, how can you move? Can you move like human beings? Bend, crawl. Now they're crawling, for instance. The cleaning robots can crawl and go below the chairs and so on. Robots now actually climbing stairs, for instance. They can understand the obstacles and then avoid them and so on. And it's very important. But for driverless cars, if you treat driverless car as a robot, it must know where is the tree, where is the signal, where is the human being, where is the rock, etc. So today's robots can understand, and the movement has much more is much more dexterous. I mean, earlier the skill or the dexterity of movement was much less, was restricted. Now it is much more, but still there is a lot that is still wanted. By the end of the century, it will certainly increase. Then there was natural language processing in artificial intelligence. Natural language processing is very important, very, very important. Earlier, you could communicate with the computer only on structured languages like SQL, Java, C, C++, COBOL. And then there are if-then else statements. Each stop or full stop or comma has a specific meaning in those. But you don't, when you talk to the mobile saying that I am now in Satara and at a particular place and I want to go to a Chinese restaurant, please tell me which is the nearest Chinese restaurant. You say that in your language, by the way, whether English or Marathi, etc. This is natural language. How does the computer understand it? I mean, we in IIT, I mean, not we, but IIT computer science people had learned compilers. When a programming language is written, it has to be converted into machine language ultimately before it is executed. So, how do you convert the natural language that you speak? How does the machine understand? So, your audio has to be converted into text, text has to be fed to the Google, Google has to understand that, search using Google Maps, etc., where you are, and then search where the Chinese restaurant is, and then take that address and maybe put that out orally. I mean, this is very complex, please understand. But it does it because it understands the natural language. How does it know? I mean, so the natural language processing is very interesting. How the compiler construction, Nuth has written a great book, but I think the compiler construction of the natural language is very complex. How does it understand? Okay, the tokens and so on. But we have made a great progress in that. But the real final revolutionary change came with machine learning and deep learning. There's a long story because of paucity time. I won't go into how actually it began, but around 2000, they wanted to have a translation software for automatic translation. And they tried with the if then else rules. Especially it happened in Canada, because Canada was ruled by France and England both. So there are hundreds and thousands of documents, especially government documents, right from village level to the central government, that had to be translated from either this language or that, etc. And so they had employed hundreds of translators. So can you do it automatically? Can you write a program which will translate? So they initially wrote a program which was like symbolic, if then else, if this word then that word, if this phrase then that phrase, right? If English then the, so essentially almost giving two dictionaries and given some if then else statements. Could you do this? They tried to do that, by the way, but they failed because it became cumbersome. The way expert systems have failed, mostly failed. There's still some expert systems which are being used by the ELISA and so on, but expert systems more or less are not used very widely today. Then those if then else statements kind of thing, of this did not work very well. Then somebody had a brainwave, and that person asked, how does a child learn? You don't teach a child the rules of grammar. This is verb, this is noun, this is adjective. You don't teach the child the rules of grammar. The child just learns by hearing the sentences. So data. So by using data, the child learns and forms the rules. So it's a reverse of what used to happen in computing all these days. All these days in computing, you used to feed a program like payroll, and out came the report pay slip, that is data. Now you're using data as an input and finding out the patterns or rules, algorithm, that is artificial intelligence. Artificial intelligence in one sentence is nothing but understanding patterns within data. When we measure, by the way, there are 6-7 types of intelligence. I've written that in my book called Manath. When Gardner, the American psychologist, says musical intelligence, spatial, S-P-A-T-I-L, spatial intelligence, a variety of types of intelligence. But when we measure intelligence in aptitude test, for instance, what you really essentially measure is whether somebody can recognize patterns or not. 1, 3, 5, 7, what is the next number? Or what is the odd man out? So essentially patterns. Can you understand the pattern? That is the crux of what we understand as intelligence, which in my opinion is only partial understanding, because intelligence is far more wider connotation. Let's not go into that. Let's understand intelligence is pattern recognition. So AI can we recognize patterns by the machine? Can we feed data to the machine and machine can understand patterns? This is the essence of data science, essence of data analytics, essence of machine learning, and essence of deep learning. In order to do that, they said, can we mimic the way brain works? Brain has billions of neurons and they are connected to each other. They are actually not connected. There is a small gap which is called a synapse, but let's assume that they are connected. And when we think about something, or when we emote, for every emotion or any thought, or any learning is repeat, whatever you see when you think or when you have emotions, there are some brain circuits which are formed or disconnected, connected or disconnected. And learning means repeated connections of those circuits essentially. So you learn that. So can we simulate that in machines? So if instead of neuron, can we have an artificial neuron? And can we have layers of these neurons? So the thought of layers on each layer there are hundreds and thousands of neurons, and imagine that there are several layers of these AN and artificial neural networks. So several layers, and all those layers, each neuron on each layer is connected to each neuron of the next layers each neuron, and earlier layers each neuron. So it becomes a very, very well connected network. And each layer learns something and passes on something to the next layer with some weights and so on, which is, I wouldn't like to explain that right now. I'm sure many of you must probably know this, but in my AI book I have explained with very simple examples and a little bit of mathematics. But I think important thing is each layer learns and then passes on to the next one with some weights. Next one learns something and passes on to the next, and so on and so forth, until such time the last layer actually arrives at some conclusion. Can we do that? And if the layers are quite a few, it's called the deep learning, otherwise it's called the machine learning. So essentially, for our understanding, deep learning is a part of machine learning, and machine learning essentially is using these artificial neural networks. Can we feed data, and can we understand the patterns within that data? I mean, in very simple terms, that is what AI is, and data analytics and data science is all about, in very simple terms. Now that can be done in two ways. One is supervised learning and unsupervised learning. I'll give you an example of unsupervised learning. Unsupervised learning means you're not saying, you're not telling what you're looking for. You're just feeding large amount of data and then asking the algorithm to find some relationship between the data. For instance, there's a bank and there are 50,000 customers. For each customer, the height, weight, sex, the degree, post-graduation degree, the salary, the marital status, the address, whether it is a car, whether it is a house, all that data, bank balance, all that data is given of 50,000 people. And then you say, find out any relationship between them. Now, that's why statistics is important. That's exactly why I wrote a book on statistics. In my book on statistics, there is a chapter on data science, and in my book on data science, there is a chapter on statistics. The reason is very simple. That supposing you want to find relationship, is there a relationship between height and salary? The machine doesn't understand, the software doesn't understand. So it tries to find out, take the heights of hundreds of people, salary of hundreds of people, try to match. In statistics, I'm sure you know that there's a coefficient of correlation. If it is 1, then there's a complete relationship. If it is 0, there is no relationship. And there are many other ways of finding out there are relationships or not. So you find out whether height and salary has any relationship or not. You won't find any, and similarly it will match a variety of such columns or attributes or properties of the customer and find out the relationships, and there are multiple. If the height is less than 5 but the salary is this, then will he have a house of his own? I mean, I'm just giving an example. So doing that requires enormous amount of permutations, combinations, statistics, mathematics, and so on and so forth. So supposing by doing that, if the algorithm or if the software comes up with a relationship saying that if you are a graduate, if you are a postgraduate, and if you have 3 years of experience and you are MBA, then you are likely to buy a car and the probability is 90%. Look at this. This is so beautiful. If this is given, this conclusion is given, then they will give the mobile numbers of those who are postgraduates and MBA and this, etc. and give it to their call centers and lagao. Do you want a car loan? Do you want a car loan? Do you want a car loan? The hit ratio is going to be obviously far higher than if you have to check with 50,000 or a lakh of your customers. This is just one example of unsupervised learning. With supervised learning, you are showing what you want to. Suppose you want to teach the machine to learn how to recognize a cat. So you show the picture of the cat. How do you show, how do you communicate is something that I won't like to discuss because it's outside the scope of this lecture. But show the side of the cat. Then the first layer maybe looks at the legs and says there are 4 legs. So maybe the probability of it being a cat is 20%, probability of it being a dog is 20%, elephant is 20%, etc. All that. The next layer looks at whiskers maybe. The next layer looks at eyes. The next, etc., etc. And passes on what is the likelihoods and the probabilities of the next layer with different weights. If the last layer concludes that it is not a cat, but it is a rat or some other, then actually there's a back propagation algorithm. I've again discussed it. If you, in very simple terms, if you are interested, look at those books. But I think it goes back, changes the weights, and then again goes forward with the algorithms until such time the last layer gives an answer of a cat. Now, so I'm sure you can understand how it does it. This is a very simple, it doesn't do it, this is simplistic. It doesn't actually do it this way, but just for us to understand what is the supervised learning. But then, if you can teach a machine to recognize a cat, you can teach a machine to recognize a lion and all animals and all plants and all things like signals, like driverless cars have to understand what is the signal, what is the obstacle, what is the rock, what is the man, what is the person, etc. How does it do it? Because they actually move the car through the cities and capture the data and learn. Learning from data is machine learning. learning from the data and understanding the patterns and understanding or concluding about patterns or algorithms or rules is machine learning, and it requires multiple layers and it's deep learning. So that is essentially the simplistic, I would say, not really the accurate, but simplistic understanding. But I thought I'll part with this because it's very important for us to understand what is machine, because these things are being talked about a lot. Now its consequences are very large. If we show, let's say, throw the mouth cancer patient to a machine, for instance, 100, 1,000 such patients, for 1,000 first patient, it will recognize that this is a mouth cancer. But this is trivial because you can recognize even sort of with your naked eye, you can recognize that there's something wrong, right? The way they show in the advertisements and so on with tobacco eating and so on. But then, today ECG, MRI, X-ray, your blood reports, everything is digital. Supposing there is a ailment, hypothetical, I don't understand medicine really, but supposing colitis, and if it is colitis, on the X-ray a particular patch is darker, and blood report hemoglobin is less than 2. I mean, just saying, and ECG it shows something else. So if you show 1,000 such reports of the patients, and there are all these reports which are now digital, and teach using supervised learning that please understand that this is colitis. Look at X-ray, look at this, and teach to recognize what is colitis. The 1,001st person, you give all the reports, and the machine will diagnose that this is colitis. That's all I'm trying to say. So in tomorrow's world, medical diagnosis, I'm saying 100%, but it's going to be an enormous help to the doctors. So roles of with robotic surgery, roles of surgeons will change. With help in diagnosis, roles of the physicians will change. With natural language processing, and chat GPT, roles of lawyers is going to change. With driverless cars, crores of drivers will be thrown out of jobs. I mean, this is going to be a change. Plus, as I've said, if the middlemen are out, then it's going to be what will happen to real estate and what will happen to the crores of people working in those shops. I think that tomorrow the world is going to be a change place for sure. The point is that the rate at which the changes are taking place, that rate is going to be very, very high. One sociologist has said that each one will have to take up 6 careers. Or you have to change jobs 6 times. Change jobs does not mean changing from Citibank to Bank of America or by TCS to Infosys. Changing job means forget the way you were doing things and learn the new ways of doing things, because the way you were doing things has become obsolete. That's why I gave you an example of ATM, CAD CAM, variety, DTP, and variety of things. With animation software, Walt Disney employed hundreds of artists in his garage in California. If you wanted to show in the animation film a cat running from one end to the other end, one artist used to draw a picture of cat at this end, then another picture with cat having moved a little bit, then third having moved still a little bit, and so on until the last picture showing the cat at the other end. Shoot these pictures, put them on disk and show them at more than 10 per second, because each picture is retained on your retina for 1/10 of a second. So before the first one fades away, the second one falls in your retina. Before the second one fades away, the third one falls in your retina. It cheats your eyes and makes you believe as if the cat is running. But then for 1 second, if there are 10 pictures, for each minute there are 600 pictures. For 1 hour, when you're sitting on your couch and then watching Tom and Jerry film, there are 36,000 pictures. Now, luckily, you didn't have to sort of draw pictures anew every time, because you had some tricks, tracing and so on. But still the efforts was non-trivial. But with animation software, you give me a picture of cat at this end, give me a picture of the cat at that end, all the intermediate pictures will be drawn by the software using graphics and rotation and stuff like that. So all the artists lost their job. The point I'm trying to make is, and with 3D animation, you can do anything. The Colgate toothpaste on somebody's hands can just fly and go to somebody else's hand. I mean, Newton would rotate in his grave, I mean, I talked about gravity and what is happening. With 3D animation, you can do anything. With if there's a rule tomorrow that no animation is allowed, then many films cannot be made. The advertisement industry will collapse, and the first person who will commit suicide is Rajnikant. So basically, it is again the point is that obsolescence, the way you used to do things, is going to change, and it's going to change far more rapidly. So that is the message that I want to sort of pass on. And in this, I want sort of like IoT, IIoT, and blockchain. I'm very proud that has been explained very in simple terms in my book. But I think the distributed ledger, and it is going to have a tremendous impact. Bitcoin is only an application of blockchain. Blockchain is solid. I mean, it's really going to have enormous impact on the governments and the way we run any organization. So basically, Industry 4.0 it comprises all these technologies together, AI being the most important, and within AI, machine deep learning being the prominent, and now the large language models. And example of that is ChatGPT. Because until now, you used to feed data and it used to conclude or find out patterns. But with large language models, it's called a generative AI, because you are generating something new. I won't go into how the transformer logic and tokens and how it does it, etc. I don't want to advertise, but please go read my books. But I think important thing is that with large language models, it generates. If it can generate one sentence, it's just an example. When you're typing, it suggests you the next word, for instance, right? So if you can suggest you next word, if it can actually generate one word, then it can generate one sentence. Then it can generate a paragraph. Then it can generate a page. It can generate the full article, and then it can generate the full book. Again, it's a question of patterns. If you show 100 pictures of Van Gogh and then give the algorithm some theme, that there's a hut and there's a moon and there's a railway going, etc., and there's a field, and draw a painting in the style of Van Gogh. So initially, if you are shown using supervised learning, it has understood the pattern. What colors does he use? How does it draw? And then it can draw a picture. If you give a theme, it can draw a picture in the style of Van Gogh, who is dead many decades ago. So I think that is the most important thing, and it can give rise to many good, bad things. It can actually use your face and pose as threat. There are many security threats and there are surveillance issues, and I won't go into that. So Industry 4.0, now Industry 5.0 is going to be the thing of tomorrow. And I'm very glad that you are having this seminar, by the way. I'm extremely glad. And that's the reason I wrote these books. I must tell you this. I'm running 75. And I'm writing books which people 18, 20 and 24 should have written. But I was so excited about this technology. And I'm extremely committed to doing something, writing something as accurately as possible, but as simple terms as possible, as I have done in economics, psychology, maths, and music, literature, etc., law, with 55 books to my credit, in Marathi and 4 in English. But I think the important thing is to simplify without compromising the accuracy, which is why I wrote a book on artificial intelligence, then data science, Industry 4.0 to 5.0 is the title actually. And then Infotech. I would urge all of you to read Infotech, because anybody, 10th standard, and read it from a library, you don't have to buy it, read it from a library if you want. But I think I have explained all technology, not just for Industry 4.0, analog, digital, Google Maps, how in a taxi, how do you know that you are going to reach in 20 minutes? How do you know that, for instance? How does the satellite system work? So Google Maps, Google Earth, I have explained in as simple terms, IoT, RFID, NFC, to how does mobile work, 1G to 5G, how do towers talk to each other, and how does the internet work, how does TCP/IP work, which is my favorite subject. I used to take lessons on TCP/IP. In my book on English, data communications and networks, I have a 100-page topic section on TCP/IP, and I've had a good pleasure of meeting Winton Cerf, who was the inventor of TCP/IP, twice in New York and twice in Taj Mahal in Mumbai, interviewing him in public. So I mean, TCP/IP is just superb. I mean, so it's poetry in my opinion. So all that I've explained in Infotech. So I think whether you read these books or any other books, but please make sure that whichever area you are in, mechanical, civil, whatever, you must at least be acquainted with what's likely to happen tomorrow, because it's going to affect all of us, all walks of life. I think it's quite timely that you are holding this seminar. I must congratulate you for taking this initiative, and Rotary Club for taking this initiative. It's a great thing that you're doing to the whole initiative. I don't see too many, industry 5.0 at that. I mean, this is really very important. I wish you all the best, and thank you very much.